Hello, my friends. I am here at STOBER in Kentucky. Now, STOBER is a German company that's been around for almost a century. Can you believe that? And we've been invited in to share the story, a really incredible story actually, of a combination of Nakamura Tome, HAINBUCH Work Holding, and Meredith machines. Now, Matt's waiting inside, Landon's waiting inside, and the story we're going to tell is about extreme precision, multitasking, reducing operations, and being able to do, let's say, operations that we couldn't do previously on multiple machines, now being done on one to a micron level, something that maybe some of you have never seen before. So let's head inside, say hi to Landon, and see what's going on. Well, we've made it inside at STOBER. So excited to be here, standing in front of a Nakamura machine with my buddy Landon. We're going to talk HAINBUCH today, but Shogo, shout out to you, amazing machine. We're going to talk about what happens when you combine the technology of Japan with the precision and rigidity known as HAINBUCH in Germany. And Landon, no better guy in this building, don't tell his buddies out there, no better guy in this building to tell this story, Landon. So let's talk about some of what you've accomplished and why you like the HAINBUCH product in your multitasking Nakamura machines.
The HAINBUCH centroteX system just makes it so easy to switch from, say, bar feeding 1 5/8" material to gripping onto a casting, 8-inch casting or 8-inch piece of bar stock. You pretty much use the centroteX, pop one head off, pop the next on, and you're good to go.
It's a great start, Landon, because I often talk about a bar feed. We often talk about the flexibility of popping one of the chucks out and popping one in. But for you to say, oh, by the way, we're going to pause our bar feed and we just got to go to an 8-inch bar with just one piece going in. So I have to ask you, very important question, because much like myself, the rest of the world is fighting this problem. How long is your changeover when you do that?
15 minutes.
For me, it was hours. Hours, Landon. And I would say a lot of that time was making sure that it was aligned. And when you put that thing in for 15 minutes changeover, are you then also taking out all of your measuring equipment to make sure that it's perfect, or is the truss there?
The truss is there. You slap it on, index it in, tighten your bolts, just do, everything as you should in your instructions, and we're good.
I want to talk about real quick the value of that alone, because the world, oftentimes, we are adapting to modern technology. You've adapted really well, by the way, congratulations.
Thank you.
But a lot of us are a little slower to implement, and we don't realize often when we're looking at money and time and cost savings, we think about a part actually being physically run, but we don't often think about that changeover time or moving a part from machine to machine, which happens so often, which is why Nakamura comes into play. But what value do you place on being able to get a part done inside of here with almost zero changeover time to get the next part running again?
For our business, it's imperative. We don't run, say, 1 million of one part or 200,000 of another. We're a very high mix, low volume. We'll run 300 or 400 pieces of this, 200 of that. And so we have to have quick, setup times. So for us just to be able to change a chuck in 15 minutes to go from a part this big to this big, I don't know if I could put a value on it.
Yeah, I would agree with you in the sense of it's not 1 million parts. You're changing this so often.
Yes.
That's so much value in itself. I want to dive a little bit more now into precision and rigidity. And I don't know if you know this or not, Landon, but I saw a bucket of parts over there, so I stole one. Don't tell anyone I stole one, but I want to talk a little bit about this part because, this looks like, I'm going to use this word, a delicious part. And I know that previously you used a couple of machines to make this, and there's a little bit longer cycle time. So let's dive into this part, what the micron precision is in it now, the combination of putting it all into one machine, and you're trusting the HAINBUCH product to come with this precision and reliability and rigidity over and over and over again.
So this is one of our more demanding applications that we've faced since I've been here. This is an input coupling for one of our MGS gearboxes, and the coupling pinion that presses in here, this coupling is assembled with a couple bearings, pinions pressed in. It's the input of the gearbox. So this gets all the abuse, all the RPMs, everything. And as far as machining it goes, the bore tolerance is 11 microns. So plus 11 minus nothing. That's all you got.
That's incredible.
Yes. So for us to do that, we have to have everything perfect, and there's tight run out, all that. So we were making it on a couple different machines. We would turn it, do our gear cutting, and then we would rough the bore. Once it comes out of the lathe, doing all of that, we would place it in a mill, and it would come in, probe, and ream it. We don't have to do that here. And so the part comes out complete, we ream it inside the lathe, and over a whole span of one shift, about 50 parts, 1 micron change in bore diameter.
Wow.
The whole day.
Wow.
1 micron. That's like a grind.
That is, and you're doing it within the machine, Landon. I mean, 11 microns, 1 micron of variation from 2 machines to 1 machine, probably several minutes of cycle time of reduction in that, not even including going from the middle process of whether it sits for a day before it gets the next part done, or just the time from one machine to another. Let's bring this all full circle and wrap up this conversation, Landon, because I look around, I see some, well, it's a big ass fan, so pardon my French, but that's literally what they're called. But I see big ass fans, I see some of the machines you have here. What kind of parts do you make, and how important is the precision and this reliability day after day? And I know you said it's everything at the beginning of this conversation, but what parts are you making so the audience fully knows what you're doing at STOBER and why this is so incredibly important?
So at STOBER, we provide drive solutions. So not just the gearbox, we build servo motors here. We sell drives, cables. So anywhere that there's motion needed, precision motion needed, that's where we seem to win the business with our customers. We hold the tightest tolerances, lowest backlash, most demanding applications. Those are the ones we go after. Those are the ones we want. And a lot of other companies say, no, we don't want to deal with this.
And this is the reason why you invest in the best, right? Could you imagine what would happen with all the scrap, downtime, rework? That would just be the most frustrating thing. So invest up front, get it done, and then make that money and get the jobs no one else can do.
That's right. So you could see we invest in the best machine tools, best work holding, best tooling. We have to have it because our customers demand the best. So for us to hold a 1 micron variation on a bore all day long, it doesn't happen by chance. You have to do some investment and really have a solid process.
It does not happen by chance. A really great way to end this conversation. I'm going to keep this. I know you don't mind. He doesn't mind at all. Yeah, a little memento. Landon, thank you so much. I appreciate your time. I'm going to step back outside and bring this all to a full conclusion, but truly amazing. Thank you for opening your doors to us, and I've really enjoyed spending time and learning more about your process.
Oh, our pleasure. Thanks for coming to see us.
Since 1997, STOBER's been doing it here, almost a century in Germany, and they continue to grow and expand on their capabilities through partnerships like Meredith Machinery, through Nakamura, through HAINBUCH, and everything in combination to make sure you're getting the precision that you want. And now officially, as you can see, I'm a member of the team. Thanks, Landon.